Hello students, in the last class we were studying about inverse of a matrix. I think you have understood inverse of a matrix exists only for non-singular matrices. If the inverse of a matrix exists, it is always said to be unique. Then we have understood about reversal of inverses. AB whole inverse is equal to B inverse into A inverse. In the last class we have studied and solved problems based on these concepts. And afterwards, I have told you about the characteristic equation. Suppose a matrix of order 2 cross 2 is given. We used to get an equation out of the particular matrix in second degree, and using the characteristic equation you can find out the inverse also. Similarly, we have found out for 3 cross 3 also. For 3 cross 3 matrix we have found the inverse and we have formed the equation, then we have found the inverse also. So last class we have solved all the problems including worked examples. As I have already told you, today in this class we are going to discuss with another important concept called consistency of the equations. Suppose students, let us consider we have 3 equations: a1x plus b1y plus c1z is equal to 0, a2x plus b2y plus c2z is equal to 0, a3x plus b3y plus c3z is equal to 0. Or you can take it as some d1, d2 and d3. These 3 are the equations we have. We have 3 equations in 3 variables x, y and z. So you know how to solve this set of equations. When we solve this set of equations, suppose if you get the value of x and y, so x, y and z, if you get the value of x, y, z after solving this, and suppose if the value of x, y, z are unique, then the system of equations are said to be consistent. Remember, if given 3 equations in 3 variables x, y, z, if the value of x, y, z exists and if it is unique, then the system of equations are said to be consistent. Suppose if the value of x, y, z does not exist, then we say that the system of equations to be inconsistent. So remember, if the solution x, y, z exists, then the system of equations are said to be consistent. If the solution does not exist for x, y, z, then they are said to be inconsistent. You have to understand, learn these concepts. Now we are going to discuss how to solve this set of equations. We write to solve the system of equations by inverse of a matrix. By inverse of a matrix. Or it is also called as matrix method. We call it as matrix method. Very, very important concept. How to solve the system of equations by matrix method. Remember students, one problem will be definitely asked in the examination for 5 marks. You need to understand the concept. Let us solve how to consider this. Let us consider the matrix here. First, ensure whether these x, y, z are in order and constants are written on the RHS. That we have to ensure. First, form the matrix A by using the coefficients. Which are the coefficients here? A1, B1, C1, A2, B2, C2, A3, B3, C3. This is called as matrix of coefficients. Please understand, these are called as matrix of coefficients. Let us form another matrix X. It is a column matrix. It is formed using the variables in the 3 equations. The variables. We call it as matrix of variables. Matrix of variables. Next, you form another matrix, that is column matrix, using the constants which you have, D1, D2 and D3. We call it as matrix of constants. I call it as matrix of constants. So I think you have understood how to form the 3 matrices. One is matrix A, which is formed using matrix, that is the coefficients. Second matrix is X, it is the matrix of variables. Third is the matrix of constants. So above system of equations, above system of equations can be written as Ax is equal to b. See, multiply a1x plus b1y plus c1z is equal to d1. That is the first equation. a2x plus b2y plus c2 is equal to d2. That is the second equation. Third row, a3x plus b3y plus c3z is equal to d3. That's for the third equations. So given system of equations can be written in the form of matrix as Ax is equal to b. So multiply both sides by A inverse from left. So what happens now? A inverse into A into x is equal to A inverse into B. What is A inverse into A? So A inverse into A is nothing but I into x is equal to A inverse into B. A inverse into A is always I. What is I into x? It is x. X is equal to A inverse into B. So that's what we have to find. We have to find out the matrix of variables. That matrix of variables is equal to A inverse into B. Obviously, what is that A inverse? 1 by determinant A into adjoint of A into B. So we have to find out A inverse and then multiply it by B to get x. X means the column matrix XYZ. So when you get the column matrix XYZ, obviously XYZ value are obtained. Then if XYZ value are obtained, then we say that the system of equations is consistent. Suppose if determinant A becomes a 0, then we conclude that obviously A inverse does not exist. When A inverse does not exist, we conclude that the variables do not exist. In such a case, the set of equations are said to be inconsistent. You have to remember this concept. I think you have understood. Given the set of equations, first you have to ensure that whether x, y, z are in order and constants are written on the RHS. First form the matrix of coefficients, then matrix of variables, then matrix of constants. The system of equations can be written as Ax is equal to b, then multiply both sides by A inverse. You will be getting x as A inverse into b. A inverse is given by 1 by determinant A into adjoint A. So using that concept, you can find out the value of xyz in the given set of equations. I think you have understood what is the procedure actually. Let us try to solve problems in the exercise. Let us consider the exercise problem. First problem, you have to check whether these equations are consistent or inconsistent. So first problem, x plus 2y is equal to 2 and 2x plus 3y is equal to 3. First form, the matrix A, 1, 2, 2, 3. What is x? X is given by x by column matrix. The matrix constant, it is 2, 3. So what is the solution? X is equal to A inverse into B. This is the solution. Let us find out determinant A. What is determinant A now? 1, 2, 2, 3. What is the answer? 3 minus 4. Determinant A is equal to, you get minus 1. Let us find out adjoint now. Adjoint for first element, let us find out A11. A11, leave the true on column, it is 3. What is A12? For this element, sign is minus, leave the true on column, it is minus 2. Then A21, the sign is minus, leave the true on column, it is minus 2. Next we take A22, the cofactor of 3, so it is 1. So let us find out cofactor matrix. Cofactor matrix will be obviously 3 minus 2 minus 2, 1. What is the adjoint of the matrix A? Adjoint is given by 3 minus 2 minus 2, 1. 3 minus 2 minus 2, 1 will be the adjoint. So you check properly. We have got 1, 2, 2, 3. So what is the cofactor? First element cofactor is 3. The cofactor of second one 2. It is minus 2. cofactor of 2, it is minus 2. So this A22 is equal to 1. So that's what we have got. So minus 3, 2 and minus 3, minus 2, minus. What is A inverse now? What is A inverse? A inverse is 1 by determinant A into adjoint A. What is the determinant A you have got? Please see, determinant A is said to be minus 1 into 3 minus 2 minus 2, 1. So what happens now? A inverse? A inverse will be multiplied throughout by minus 9, minus 3, 2, 2, minus 1. So this is what A inverse is. You need to find out X, A inverse into B. What is A inverse? Minus 3, 2, 2 minus 1 into B. What is B now? We have found matrix B, it is 2, 3. So what is the answer? Minus 6 plus 6, 4 minus 3. That's equal to 0, 1 you get. That is what X. So the matrix of variables X, Y is 0, 1. That implies X is equal to 0 and Y is equal to 1. For cross verification, you put X is equal to 0, Y is equal to 1, 0 plus 2 into 1, 2, LHS is equal to RHS, 2 into 0, 0, 3 into 1, 3, 3 is equal to 3. So we have got values for X and Y which are said to be unique. Since the values are unique, we conclude that system of equations are said to be consistent. Suppose if the inverse does not exist means, or if the X and Y value does not exist means, system of equations is said to be inconsistent. You have to write a conclusion that system of equations is consistent because you have got unique values for X and Y. I think you have understood this problem. I move on to the next problem now. It is given 2x minus y is equal to 5 and x plus y is equal to 4. This is what given. X plus y is equal to 4 it is given. So first form the matrix A, 2 minus 1, 1, 1. What is the matrix of variables? It is xy because we have only two variables. You take B, matrix of constants, it is 5, 4. Now let us find out X. X is found using A inverse into B. What is A inverse means? Determinant you have to find. Determinant A, it is 2 minus 1, 1, 1. What is the answer? 2 plus 1, which is equal to 3, not equal to 0. So matrix is non-singular, hence the inverse exists. Let us find out adjoint. A11, cofactor of 2, it is 1. A12, it is minus, leave the thrown column 1. Let us take up A21, minus, leave the thrown column, minus of minus 1 plus 1. Then A22, it is plus, it is 2. So let us find out cofactor matrix. Which is the cofactor matrix now? Cofactor matrix of A, 1, minus 1, 1, 2. What is the adjoint of the matrix here? What is the adjoint? Transpose of the matrix of cofactors, 1, 1, minus 1, 2. I think you have understood how to find out the adjoint. So we can also do it directly by interchanging the diagonal elements, changing the signs of the other elements. A inverse is 1 by determinant A into adjoint A. So it is 1 by 3 into 1, 1 minus 1, 2. Now what is required? You want X. X is given by A inverse into B. A inverse is 1 by 3 into 1, 1 minus 1, 2. Into what is B? B, the matrix of constants is this 5, 4. 1 by 3 into 5 plus 4 minus 5 plus 8. What is the answer? 1 by 3 into 9, 3. So you will be getting 3, 1. That's what X meant. So if you equate, X will be 3 and Y is equal to 1. Verify. 2 into 3 6, 6 minus 1 is 5. 1, sorry, y is 3 and y is 1, 3 plus 1 is equal to 4. So we have got values of x and y. Since value of x and y are unique, we conclude that system of equations, this system of equations is said to be consistent. Please understand the problem. First we have to find out the determinant A, ensure that the matrix is non-singular, then find out the inverse. Then it's very simple. In a simple way we can solve the answer and get at the desired result. I move on to the next one. X plus 3y is equal to 5. 2x plus 6y is equal to 8. Okay. So what is the matrix of coefficients? 1, 3 and 2, 6. What is the matrix of variables? It is x, y. What is B? The matrix of constants? 5, 8. What is the solution given by? X is equal to A inverse into B. So what is A inverse? A inverse is 1 by determinant A into adjoint of matrix A. Now it is very important to find out determinant A. Find out determinant A. It is 1, 3, 2, 6. So what is the answer? 6 minus 6. Determinant A is said to be 0. When determinant A is 0, there is no chance of getting A inverse because 1 by 0 is infinity, so that is not defined. Hence, since determinant A is 0, it is not possible to find out the inverse. When we cannot find out the inverse, A inverse into B does not exist. So we say that x and y value does not exist, hence the system of equations is said to be inconsistent. Remember students, when you get the values of x and y, then we conclude that it is consistent. When x and y value are not obtained from the given set of equations, the system of equations are said to be inconsistent. You have to understand this concept. If you have understood this, we move on to one more problem of 2 cross 2. 2 cross 2, one more. Five x plus 2y. 5x plus 2y is equal to 4 and 7x plus 3y is equal to 5. This is the problem given. First find out A. What is A? Matrix of coefficients 5, 2, 7, 3. What is the matrix of variables? It is x, y. What is the matrix of constants? It is 4, 5. So, solution is given by x is equal to A inverse into B. So, we have to find out determinant A. 5, 2, 7, 3. It is 15 minus 14. This is equal to 1. It is not equal to 0. Hence, inverse exists as the matrix A is non-singular. Let us find out A11, coefficient of 5. Leave the thrown column, we get 3. You find out the coefficient of 2, it is minus 7. You find out the coefficient of 7, it is minus 2. You find out the coefficient of cofactor of 3. Cofactor of 3 is nothing but 5. So what is the cofactor matrix of A? This is 3 minus 7 minus 2, 5. I think you have understood this. Let us find out the adjoint of the matrix, transpose of the matrix of the cofactors, or interchange the diagonal elements, change the signs of the other elements. What is A inverse now? A inverse is 1 by determinant A into adjoint A. What is determinant A now? Determinant A is 1 into adjoint A is 3 minus 2 minus 7, 5. A inverse is, or multiplying throughout by 1, 3 minus 2 minus 7, 5. What is x now? X is A inverse into B. 3 minus 2 minus 7, 5 into B, the matrix of constants. It is 4, 5. What happens now? 12 minus 10 minus 28 plus 25. What is x is equal to now? it is 2 and minus 3. So it is, when you equate, you will be getting x as 2 and y as minus 3. Verify. 5 into 2, it is 10. 2 into minus 3, minus 6. 10 minus 6 is 4. So if you substitute these values of x and y in the equations, it will be satisfied. That means value of x and y exists, hence the system of equations are said to be consistent. You have to conclude that system of equations are consistent. So I think you have understood. Please understand, and the same concept can be applied to find out 3 cross 3 also. Take up the next one. 2x minus y is equal to minus 2. 3x plus 4y is equal to 3. That's what we have. First we find out the matrix A. It is matrix which is formed using the coefficients. X is the matrix of variables and B is the matrix of constants. Minus 2. So what is the solution given by? Solution is given by x is equal to A inverse into B. So to find out A inverse, first we need to find out determinant A. 2 minus 1, 3, 4. So what happens now? It is 8 plus 3, 11, which is not equal to 0. Now let us find out the adjoint. To find out adjoint, we need to find the cofactors. A11 will be 4. What is A12? Minus 3. What is A21? Minus of minus 1, which is plus 1. A22, that is equal to 2. So what is the cofactor of the matrix A? 4 minus 3, 1, 2. What is the adjoint of the matrix A? Transpose of the matrix of cofactor 4, 1 minus 3, 2. This is what adjoint A. Now let us find out A inverse. 1 by determinant A, it is 11 into adjoint A, 4, 1 minus 3, 2. This is what adjoint. Now you can find out the value of x using x is equal to A inverse into B. 1 by 11 into 4, 1 minus 3, 2 into, what is B here? B is minus 2, 3. So 1 by 11 into minus 8 plus 3, then it is 6 plus 6. So let us see what is the value we get for x. It is xy. So you will be getting minus 5 by 11. This is 12 by 11. What is the value of x? Minus 5 by 11. Y is equal to 12 by 11. So if we substitute the values of x and y there in the given equations, it will be verified. Remember students, as the value of x and y exists, the given system of equation, this system is said to be consistent. As I have already told you, if x and y does not exist, or that means A inverse does not exist, then we say that system of equations are inconsistent. Let us take up one more problem. 4x minus 3y is equal to 3 and 3x minus 5y is equal to 7. This is the equation. So let us find out the matrix A, which is formed by using the coefficients 4 minus 3, 3 minus 5. And what is the matrix of variables? It is xy. What is the matrix of constants? It is 3, 11. What is the solution given by x is equal to A inverse into B? So to find A inverse, you have to find out determinant A, which is 4 minus 3, 3 minus 5. What is the answer? Minus 20 plus 9, minus 11, not equal to 0. So let us find out the cofactor of 4, it is minus 5. Cofactor of minus 3, it is minus 3. What is cofactor of 3? It is minus of minus 3, which is equal to plus 3. A22 cofactor of minus 5, which is equal to 4. What is the cofactor matrix? Minus 5, minus 3, 3, 4. What is the adjoint? Adjoint of the matrix A, minus 5, 3, minus 3. You have understood? Minus 5, 3, by minus 5, 3, minus 3, 4. So what is A inverse now? A inverse is given by 1 by determinant A into adjoint. What is 1 by determinant A? Minus 11. Adjoint of A, minus 5, 3 and minus 3, 4. This is A inverse. What is X given by? A inverse into B, minus 1 by 11 into minus 5, 3, minus 3, 4 into B, matrix of constants. It is 3, 7. Let us multiply. Minus 15 plus 21, minus 9 plus 28. So what happens? Minus 1 by 11 into, it is 6, it is 19. So what is that matrix X? It is matrix of variables x, y. So you will be getting minus 6 by 11, minus 19 by 11. Equate x is equal to minus 6 by 11, y is equal to minus 19 by 11. Think you have understood how to get the values of x and y. So when you get the value of x and y, system of equations are said to be consistent. That's how we have to conclude. So we have solved 6 problems on by using matrix method. We have solved x and y. These are all 2 cross 2. But we have to learn how to find out x, y, z. That means how to solve the system of equations in 3 variables. That is x, y, z. Usually one problem will be definitely asked for 5 marks. You should know how to solve this problem. Now let us take one problem. X minus y plus z is equal to 4. 2x plus y minus 3z is equal to 0, and x plus y plus z is equal to 2. So you know these are the equations in 3 variables. X, y, z are the variables, and hence 3 equations are given. You have to find out x, y, z using matrix method, that is using the inverse of a matrix. So for ensure whether x, y, z are in order and constants are written on the RHS. Yes, first form the determinant matrix A, 1 minus 1 1, 2 1 minus 3 1 1 1. What is the matrix X now? It is the column matrix X, Y, Z. We have 3 variables. We have to write the column matrix. Next, to write the constant B, it is 4 0 2. Think you have understood? This is what solution is given by X is equal to A inverse into B. To find A inverse, first we need to find out determinant A. What is that? 1 minus 1 1, 2 1 minus 3 1 1 1. Think you have understood how to get this. Now find the value. 1 into 1 plus 3, minus of minus plus 1 into 2 plus 3 plus 1 into 2 minus 1. So it is 4 plus 5 plus 1. What is the sum you get? It is 10, not equal to 0. When the matrix A is non-singular, definitely inverse exists. How to find out the inverse? Before finding inverse, we need to find the adjoint. So let us find out the adjoint of each element. A11, A11, sign is plus, 1 plus 3, that's equal to 4. Let us find out A12, sign is minus for this element. 2 plus 3, 2 plus 3, what is that? Minus 5 you get. Then you find out A13, sign is plus, leave the thrown column, 2 minus 1, that's equal to 1. Next you find out A21, sign is minus for this element, leave the thrown column, minus 1 minus 1, it is plus 2. Now I find out A22, A22 sign is plus for this element, A22, second row and second column, leave the thrown column, 1 minus 1. 1 minus 1, 0. Next find out A23. Sign is minus for A23. Second row, third column, you leave the drawn column. 1 plus 1. That's equal to minus 2. Now let us find out A31. Third row, first column. Third row, first column for this 1. It is 3 minus 1. That's equal to 2. You find out A32. Sign is minus. A32 for this element. Minus 3 minus 2. Minus 3 minus 2, which is equal to 5. You find out A33. The sign is plus. Leave the drawn column. 1 plus 2. 1 plus 2, that's equal to 3 you get. What is the cofactor of the matrix A? What is the cofactor? Write it in order. 4 minus 5, 1. First row. 4 minus 5, 1. Second row. 2, 0 minus 2. 2, 0 minus 2. Write the third row. It is 2, 5 and 3. What is the adjoint of the matrix A? It is got by taking the transpose 4, 2, 2. Then minus 5, 0, 5. 1 minus 2, 3. I think you have understood how to get adjoint. What is A inverse now? A inverse is 1 by determinant A into adjoint of A. Determinant A is 10. Adjoint 4, 2, 2. Minus 5, 0, 5. 1 minus 2, 3. What is the solution? X is equal to A inverse into B. 1 by 10 into 4, 2, 2. Minus 5, 0, 5. 1 minus 2, 3. Into I write B. What is B? 4, 0 and 2. Now, to take 1 by 10 into multiply. 4 4s are 16. 16 plus 0, 16. 16 plus 4, it is 20. Minus 5 into 4, minus 20. Plus 0, plus 10, it is minus 10. 1 into 4, 4. 0 plus 6, it is equal to 10. That's equal to, you get 2 minus 1, 1. That's what X is. What is X basically? It is the column matrix X by Z. Equate X is equal to 2, Y is equal to minus 1, Z is equal to 1. I think you have understood how to get the value of X, Y and Z. Please carefully understand carefully and observe carefully and write down the answer. And students, please try to understand first the equation. In equation X, Y, Z should be in the order, and then find out determinant A. It should not be equal to 0. Then find the cofactor matrix. Then find the adjoint. Then inverse can be found using 1 by determinant A into adjoint A. Then X is equal to A inverse into B. So we get the value of X, Y, Z. Think you have understood the problems you have solved in this class. I have solved 6 problems in 2 cross 2 and I have solved 1 problem in 3 cross 3. In the next class, we are going to solve more problems on matrix method, that is inverse of a matrix. So, I think you have understood. Please practice all these problems today. Tomorrow we will solve more problems on this day. That's all for the day. Thank you.